Okay, I'm going to call the Committee of the Whole meeting for the Town of Westville to order. I'm going to start with acknowledging that we are located in Mi'kmaq, the ancestral and unceded territory of the Mi'kmaq. We recognize that without action, acknowledgement is empty. We are continually learning more about how to engage and move forward as we work toward truth, reconciliation, and equity. It marks the beginning of the work ahead of us, not the end. We are all treaty people. I also want to acknowledge the legacies, histories, and contributions of the African Nova Scotia people who have been here with us for over 400 years. With that, roll call, Councillor Dunn, CAO Weirs, to my left, Councillor Fraser, Councillor McKinnon, and Deputy Mayor McGregor sends his regrets. He's under the weather this evening and was unable to attend. And I'm Mayor Lenny White, by the way, for those of you who don't know. Declaration of conflict of interest. I don't think we have any this evening that I'm aware of. You can always declare one at any time during the meeting, but I don't think we have one. So tonight we have a couple presentations. One is going to be on our subsidence study in town, and then following that a geothermal presentation as well. So two interesting topics that CAO Weirs has been working on for the last couple of years, and we're delighted to get a report on these things this evening. So I ask CAO Weirs to introduce our speaker, please.
Thank you, Your Honor. You're right that just for folks on council and those at home, Westville has been looking at the subsidence issue for a number of years now, and the Canadian Centre for Geodetic Engineering at the University of New Brunswick has been our contractor for all those studies. So this is, I think, the second or third year, forgotten which. And it's been really helpful to kind of start to get a handle on some facts about subsidence in Westville related to, our coal mining industry that, has been long gone now for 30-some years. Who we have with us today from, looks like maybe New Brunswick. I'm not sure. Anna is often in very different places. I've talked to her in Western Canada, in multiple places in Europe over the years. So I'm not sure where she is, but it kind of looks like you might be in New Brunswick. Anna Chernowski is the professional engineer and the director of the center. And she has been the primary researcher for Westville over the last number of years. So Anna has a presentation that is up on the screen, and I will be able to show people at home here and in the room here, Anna. So you can just start your presentation and just tell me to go to next slide whenever you want me to go to next slide.
Thank you for introduction, and I can start the presentation. I have as the first few slides, it will be introduction into subsidence. It means on what we are basing our assumptions and findings. So technology plus what we found out in Westville, what are the deformations. So yes, if I could see first slide.
Yeah, I'm at the subsidence slide.
Yeah, but I don't see the...
Yeah, you won't be able to see it.
We turned her around, could she?
No, I don't see the...
No.
Yeah.
No.
So Anna, you will not be able to see the slides. So I'm on the second one that says, has the little graphic of the subsidence and the trough.
Okay, so I go to my presentation.
Yeah.
I just have to somehow make it smaller, your connection, and now it doesn't, just a second.
Yeah, sorry about that. I've used a second computer to demonstrate or to project the PowerPoint.
Just a second. I have to go to my computer, and I would like to see the presentation. Sorry, but I thought that I would see presentation on your screen.
Right.
So now I have to make it smaller. I cannot make it smaller. Just a second, I get this organized somehow. And I can. I will go to share my screen. And if I go just a second, I got really stuck PowerPoint live presentation. No, I'm not getting.
Yeah, so I think all you have to do, Anna, is just pull up just go to your PowerPoint and pull it up for yourself. So I've got it here on the screen for everybody else.
Yes, now still I cannot get. It's something wrong with, or I cannot. I have status set to do not disturb. I'm not sure why my status is not to disturb. Just go to the settings. I'm sharing my screen and I would like to see what is on my. It's horrible what I'm doing, but.
Can you just pull up your PowerPoint? And
I have in my background, but I still see you, and I cannot get to.
oh, you can't get to it. Oh, okay.
Yes, I'm fine. Yes, I'm with my presentation. So the first slide.
Can I share my screen?
The subsidence studies, and I'm going back. So
No.
This is what probably you see, and the second.
Can anybody
slide
see this now?
is,
Do I have to get in?
Subsidence information, what is causing subsidence. So this is due to the lowering the air surface due to the extraction, and in our case is extraction of coal due to the old coal mining. And if we see on this picture, if we remove the material at the bottom of this picture, we may have two phenomena. We have caving over the coal, and then we have on the surface moving down towards the caving, and we see also the extent of subsidence. So it's not only over the caving or the area which is extracted, but it has a further impact. And there is also the impact of collapse, which is a very random, and this goes very vertically towards the surface, and we have this hole which is on the surface. But this is a very small extension from the size of the coals. So this is usually happens when we have mining or mining workings very close to the surface, and also the very specific situations. In case of Westfield, we observe the problem connected with caving of the materials and moving the roof to the opening and creating the surface subsidence. Could we go to the next one?
Yep.
Number 3?
Yep, number 3.
So this is, as I said, the subsidence is mainly produced by mining, and it depends on mining method, because we may have the mining method with roof collapse or room and pillar mining. Again, extent of exploitation zone, as we saw on the picture, it depends how far the mining working are reaching. Also, depth of the exploitation zone, so how deep is the mining, and also type of overburden material. Usually, if we have a core mining, the material, so it means rock mass is more, from geological point of view, is more flexible and it's more brittle as well. So we have subsidence which really covers the area and is maximum is very shortly, reaches very shortly after the mining is completed. So can we go to the next one?
Yep.
4.
Done.
So if we see how it looks like, if we have the terrain which is undisturbed, we have the mining which goes under the surface as we see, and then we have subsidence over the mine area. So on the bottom we see how this really looks like. We have a worked area, and this is usually method which is being used in coal mining with method with the roof collapse. So as we see over the worked area, we have the collapse of the material of the roof and movement of overlaying strata which goes to the surface. If we look at the surface, we see that we have a line which, if we look at the stresses over the, which are in the rock mass in the upper strata, we have compression in the center, where is the maximum subsidence, because maximum bending of this surface, we see that maximum is over the center of the worked area, and around this area we have compression. And then further we have extension. So it's very important to pay attention or to calculate what is the compression and extension, and we calculate compressive strains and tensional strains, because if we have this on the surface structure, it will, and we have subsidence, the structure will maybe compress, so it means the foundations will be compressed or stressed, and they may start breaking. So this is how we define the strains which are on the surface. And also, as you see, the line from the edge of the mined areas to the surface, this is the special angle which is characterized for the given material or rock strata. So in each case, when we analyze, we look or we determine what is this angle, because not in all stratas we have hard rock, we have soft rock, different type layers, geological layers. So this is the characteristics of the rock material overlying the mining activity. May I have the next one, 5? So if we classify how the formations are happening and when they are happening, and we look at the time of underground mining. So when the mining is ceased, is no longer progressing, then we have direct deformations. Usually the subsidence is directly connected with the time of closing the mine or closing the area in which the mining was progressing, and it may last till 5 years. Then we have intermediate deformations which are smaller than these direct deformations, but they can also last several years. And then we have long-term deformations. They are very small deformations, but they can fluctuate and they have the subsidence trend. So they grow in value, but very slowly. And this can take really up to 35 years or longer after the closure of the mine. And this agrees with the histories from other so many years after the closure of the mine. Next, please.
Yep.
So if we look at the surface, as we can see, we have the coal, which is the black thick line, and on the right-hand side, grayish is the mining activity, excavated area. And if we look at the surface, we have this line, the bowl of subsidence, and if we see farther from this mining activity, the house or buildings, structures, number one, they are intact. The two is, we can say intact, then they start to be affected by the subsidence curve. So it means not maximum, but the curve, where they are located on this curve. And the seventh location, we see the buildings are located in the center of subsidence, but they are still, we can see, standing straight. So here we can see that, as I said before, we looked at the compressive and tensional strains. So the building, let's say number seven may be strained under compression, so, or on the surface, they can be under tension, so they can be affected. But the buildings or structures which are, let's say, 3 or 4, they are affected by the tilt, so they are tilting. And also they are bending because we have this curve, so the building, let's say number 3, it's somehow, we can see how they change verticality. Because, so if they have a common foundations, the foundations would bend and can crack. So we are looking at these different values to assess the impact of subsidence on stability and impact of the objects or buildings, structures which are on the surface. Can I have the next slide?
Yep.
So if we have a subsidence which is already fully developed and it is after the mining stopped, we have W max is a function of A times H. H is height of the mining activity, and A is the parameter which gives us information on the mining method. So it means if we have the mining with roof collapse, we would have A equal 95, 0.95 or 0.9, because the whole rock mass would go into the opening. If it's the lumen pillar mining, this all A would be, it may be even 0.5 or 0.7, and not the whole rock mass would go to the bottom. Therefore, in the beginning, it would be, let's say, half of height, let's say, transmitted as a subsidence, and with the time, if the pillars will start collapsing, it would increase. So this is why we have this long-term subsidence, is the lack of stability of the infrastructure left after the mining stopped. It may be some pillars, or maybe the strengthening of roof, and this in time starts bending, cracking, moving down. So therefore, it's a very slow process, but still it moves ahead. So next, please, if we can go. So what we analyze in findings, or when we describe subsidence, is that we look at the parameters of subsidence. As I showed on previous slide, we have again at the bottom, the dark black part is not excavated area. On the left-hand side, grayish is excavated area. And we have we have two coordinates, x, which is along of towards the function of the A, mining method and height. So it's not always the same in all types of mining. And we can determine R, it's the radius of critical area, which goes from z-axis to the right to the point where we call that subsidence is equal 0. And so we have connection between R, radius of critical area, and the limiting angle beta, which you can see at the bottom. It's a beta angle, and its connection that R is equal H times cotangent beta, and H is the depth of the mine. So can we go to the next one?
Yep.
Here. So the slide number 9, and this is what I was saying, that we determine the formation parameters. So tilt, I showed that on the side of the subsidence balls we have tilt, and the buildings are tilting. Also the subsidence curve is tilting. Then we have curvature K. So it means that it's not a straight line. So if we have foundations, it will be curved, not straight. And we can determine horizontal strains, which is epsilon x. As I showed in the beginning, we have compression and tension. And then we have also horizontal deformations plus subsidence, vertical and horizontal. I will not explain how these curves are developing, but they are all connected with the subsidence curve and maximum subsidence, the size of the mining activity, and the depth. Can we go to the next point?
Yep.
But what is of our interest is to determine maximum values of the formation parameters, because I showed you, okay, we have these parameters, and so what? We have to determine the maximum values to establish which, let's say, which of these parameters exceeds the allowable value, and how to standardize or how to, if we have this information, how to appreciate or to set if the buildings are safe or not. So we have maximum horizontal strain, which I said it's one of the parameters. The maximum horizontal movements. I will not go through the formulas because you can always look later on at them, but as I would like to show that we have the formulas to calculate exact values, and we use in all these values value of maximum subsidence. So we have to know what's the maximum subsidence, and also what is this parameter R in order to calculate these parameters. Then we can calculate maximum curvature, maximum tilt, and of course, as beginning, as was the base of this, is maximum subsidence. So in order to calculate these parameters, if it's unknown area, we have to get maximum subsidence. The best is to monitor or to measure this subsidence. So what we are doing, we are in our project and cooperation, we monitor the maximum subsidence, which is in Westfield. May I get the next one? To determine what is happening, I'm using the classification of mining terrains and deformation tolerances. This is accepted by mining industry in Poland, but also is right now adopted by province of New Brunswick. So it is and in other places as well in Europe, in Australia. So this is how we what we are looking right now, this is category, risk category 0, so it means there are no structural damages even to large structures. And next one is category 1, where they might be small damages like hairline cracks to large structures. Well, again, we can determine what's a large structures. If we have a large, long foundations, then a big plate, this may be affected, and also if it's the tall buildings. If we would be looking at the risk category 2, then is more concerning to the structures which are in Westfield, because they may be some damages to small residential housing, so this would concern people. But if any larger structures would be in planning, one should look also in category 1 if may occur or not. So can we, and then again, if we go with the categories, it's more and more the deformations affect the structures on the surface. They may be damaged, maybe serious structures and destruction. And category 5 is the useless terrain, so it means it's moving so much that the structures would be not stable. Maybe go to the next. So, in order to determine these parameters, we use INSAR synthetic aperture radar interferometry. It's a new modern measuring techniques, and it uses the satellites which are moving over the Earth on the orbit, and they take pictures of the Earth. This technology is very, very widely used in many mining situations. But it has pluses and minuses. Plus is that we can see the picture of the deformation of the large terrain, so we can detect directly if we have movements in specific areas. So we can detect the deformations, and we can have values for this movement. So it means maximum subsidence, and also from the pictures we can find what is our radius of influence. So having these two values, we can calculate the parameters and the terrain category. The problem with INSAR is that we have to have a very, very good surface from which the wave would reflect. And if it's like forest, it's not good, because instead of looking at the surface, we are looking at the tops of the trees. So of course this area will not give us a good results. The same if we have a seasonal changes like a snow, it's also not good. So we used this, but what is also good for this technology, that we can retrieve the pictures from of this area 8 years back. So we retrieved the last year from 2016. So now, using the pictures from 25 and 24, and we can determine what is happening with respect to subsidence and parameters in 2024 year, and it's what is happening in year 25. Of course, we were looking for 2016, 2018, 2000, and every year to see how the deformations or subsidence was changing in specific areas of Westfield. And I will show this on next slide.
Anna, it's Scott. Can we go a little faster? I've got another presentation. They're waiting online, so maybe just get to the kind of the findings for this year.
Yes. So this is what was happening. This is the Westfield area. The red sections A, B, and C, and in order to see what is the subsidence, and in 2025 we have also the cross-section 8. So please, next slide.
Yep.
I'll go to this one. This is how we see on the inside pictures. The orange is the large subsidence, and these are the cross-section. As I go further, next one, 15, we see how the subsidence of lane I. So we had chosen, these are the areas of interest, these are the area of subsidence. So this is what's happening, and this is along AA. This is the subsidence. We see that it's growing. We go to the next one.
Anna, can I interrupt for half a second? Can,
16.
yeah, Anna, can I interrupt for half a second? So, council and people in Westville, all those multicolored lines are all the different years between 2016 and 2024. The blue line at the bottom is in fact your findings, Anna, from 2025, correct? So you can see that that for many years the subsidence was in a fairly narrow zone, and there was more change in 2025 than I think we were anticipating to see. And so I've gone to the next slide then, Anna, so it's line BB.
Same.
Yes. Yes, yes. This one shows the same. We have, yes. It's because, as I said, we started with 2016, 2017, 2018, and so on. So these are these lines, and it's like a cluster of lines. And then if we go to CC, again, we see that they were moving down, as we see the point which is on the left-hand side was moving down as well. But as we see, there's no the same speed or the same value is not the same for each 1 year period.
Right.
It's, as they grow, as we say, they just behave the way how they behave. So it means large or smaller deformation. So we go to the next one. This is the one which we really were concerned this year. It's HH. It's the place where is this old open pit, and it's like a bare land. And this one showed much more subsidence this year than previous years. So this was what is happening in the last
In the open pit zone?
25.
So Anna, HH is, it crosses the open pit area, correct?
Yes.
Yeah.
Yes.
So in that area that has been, reclaimed 30 some odd years ago, there is still subsidence. And there was more subsidence in this last year, the blue line, than there had been. So the subsidence has been kind of, mirroring what it's traditionally done. It's just moved more in 2025 than in some of the other years.
Yes, and we look at the point, if we could look at the slide 19.
Yep.
I was also plotting the deformation subsidence in years. We are looking at right now from the 0, so it was point 2000, it means time 2016. On the right-hand side, we have 2025, and the dots are the movement of point 10, which is on the cross line A prime. The same on the right-hand side, we have a plot of the movement of point 11, also located on the cross line AA. And as we can see, they have this movement down and up, but in the last year, especially in the spring, it was quite a large movement, and the trend is the straight line, which shows that the subsidence within the years is growing. So this is the trend of subsidence. Can we go to the next one?
Yeah, I've got BB up.
Yeah. This is again line BB. As we see, it goes down, then it goes a little bit up, and then the long point.
Yeah, and I've got CC up now, Anna.
Number 21.
It's BB line which is connecting AA and C. I didn't plot here, but it
Right.
is the same phenomena that we have a downwards movement.
Right.
And if we go to 21,
Yep.
we have CC line,
Oops.
and again, it's a very similar situation. We have a down movement up to, let's say, 2023, then 24, it moves a little bit up, and then 25, we have a movement down. So the trend is that the subsidence is generally growing. It's bigger. So can we go to 22?
Yep, I've got it up, and so's the same thing. Yeah.
If we look at the subsidence of the of age cross line, we see that for like till 24, not much was happening, but in the last year we see that 2 monitoring sessions for spring and fall show downwards movement. So the trend, if you would see average, would be the lines which are the solid lines, but of course the last year 25 is more changed, so it would be interesting, so call it, or necessary to check what is going on, if it's still growing or maybe it's evening up, it's not. So this is the question, what may happen in the future. 22, 23, can we go to
Yep, at 23 now.
23? So now, as I said, we have the values, so it means we calculate, we measure maximum subsidence, we measure R, the angle of influence, and then we calculate, as I showed from formulas, tilt, maximum tilt, which is given as a allowed, what is allowed for the category 0, and horizontal strain, and what is allowed for horizontal strain.
And
So as
and
we
Anna,
see
and is it, am I correct in kind of drawing people's attention to the far right-hand side of that chart and the area category?
Zeros.
And the numbers are 0. So I think despite the fact that there is more subsidence than there had been, the reality is that it remains 0, which is something that we don't really need to worry about. We need to investigate what's going on, but there is no danger, immediate danger to structures in Westville on the basis of all the calculations you've done. Is that correct?
But we are close. I could, like, if we look at the tilt at AA cross section, measured or calculated is 0.11 millimeters per meter. For category 0, allowed tilt is 0.11. They are the same. I don't put that it crossed or it's larger, so it's 0, but it is close to the one category.
Okay, so it's getting close as a result of the,
Same if we look at C, we have 0.19 and 0.19 as a tilt. If we look at H, it's 0.37 northeast, and we have 0.37 maximum. The same if we look at the horizontal strain in direction of southeast, we have 0.09. 0.09 is the maximum. So it didn't reach higher values, but it is like 0 getting.
it's getting close, right? Okay.
To 1, because if we see that the trend is that the subsidence is growing, as I showed the trends, it's probably most likely that in some areas it will be larger and these numbers will be larger, so it may be category 1. But we have to check. In order to be
Right.
extremely, as we say, accurate, we decided to do leveling as support for the inside. Inside, as we saw, you saw, is a large area, and we can detect the movement, but we
Yep.
It's a design of leveling in this area. The top of the picture is Stellarton, so I don't talk about it. But if we see the blue lines, is the blue line where the leveling points were set up and is planned that 2026 the leveling campaign will be performed in order to get more accurate results and really to be
Right.
sure or to have any other monitoring results to verify that we are on the right path.
Right. So Anna, if I could just interrupt again for a second. So, Council, the picture in the bottom corner of 24 there is a picture of what is a geodetic monument. And so it's a concrete thing that's placed in the ground, and there are a number already, quite a number already all across Nova Scotia that have been put there over years by the government of Nova Scotia. In cooperation with Anna and her team directed the installation of about, was it 10, I think, right, Anna? 10 new monuments, so brand new monuments unique to Westville that were put in the ground last summer, last year. And so we will be using those on a go-forward basis to do the leveling measuring that Anna is talking about. And so it gives Westville, as she was saying, a more accurate understanding of what's happening.
Yes, because we are close between 0 and 1 category, and it would be really, I would say, better or advisory to get really still extra information
Right.
to confirm this. And as information is that the monuments, colors, and marks were provided by the Geonova Nova Scotia, and they will be also a part of Nova Scotia monitoring scheme. So this would also, well, it's input, I would say, extra value on the results from this monuments or from this
Right.
leveling. So it would be of interest for Westville and also of interest of Nova Scotia, Geonova. So the government.
I'm on slide 25 now.
Yes, so go. So these are what the conclusions are. So this is the areas which is where these areas are located. So it's the Drummond Road area and east of Foxbrook Road. So this is the area which is the most affected. The maximum subsidence between October 2016 and October 2025 was 0.138 meters. So it was 13 centimeters or almost 14 centimeters. And if we look at the rates, we were looking at the 15 millimeters per year, and large deformations were between autumn 24 and spring 25, and this was the increase of surface rate 17 millimeters per month. And also when we look at the tiered and horizontal strains, I just showed that they were larger, but they didn't exceed the values of allowable subsidence or strains for category 0. And what would be advisory to get the monitoring, leveling monitoring in 26, we plan to do it in spring, in May 2026 to get the first readings or results of monitoring. It's not really readings, but it's that getting readings plus analysis of the findings of the readings to have again the surface map to show what is happening when we get the monitoring results.
Right. So I've got 26 up now for you, Anna.
Bottom line.
26, when we look into 26, yes, 2026, yes.
Yeah.
Wow.
So
thank you, this is,
yeah, so
this is all what
just a couple words for council then. So what Anna and I have done is put together another application to the provincial government, to the mining department, recommending on the basis of her work in 2024, 2023, 2024, 2025, that there should be we should do more similar work to kind of try and understand what's happened last year, to give the big changes, and to give Westville a little bit more understanding of what it faces. I think importantly, Anna's pointed out that some of the big changes are happening in the kind of Drummond Foxbrook area, which we know was, there was very deep open pit mining there, and lo and behold, even though 35 years have passed, there is still compaction going on and subsidence. So it's important to follow that up. We have put together that application and are ready to send it to the provincial government at kind of a moment's notice, as it were.
Excellent.
Anything else, Anna, that we need to tell people?
I think this is all what we found in 2025, and we are looking for 2026 to see how this progressing and
Right.
how this what is happening with the subsidence, if it's the same velocity of movements or they are easing up, because it would be more interesting if we would go into this category 1, if this would go, maybe
Right.
it was just the maximum in 2025, and it will level up and it will not develop anymore.
Right.
Just a quick question on that. Can you hear me? Just wondering, like based on your knowledge and expertise in this, 2025, is that possibly because we went through such a drought during that time, or like is there any like environmental conditions that you could think that would cause that if it was so stable, not doing anything for so long? Not that it was huge subsidence that took place, but the bit that did, what would you say in your opinion caused it?
As we see the trend, even before went up to 2024, it was still downwards.
Right.
We had a little bit slowing down in 2023, 24. So therefore it was like, you may say that it was because it was stabilized, or it was again, as we may say, environmental conditions. But again, in 25 it was the growth. It may be both. It may be caused by the movement around openings or these past openings. It may be also the problems with drought. So therefore we cannot say that we close the information on or monitoring on 25. It's advisory to see what will happen 26 or 27 to see if we have 2 years of moving or not moving, then we may say yes, it's stabilized. But now we don't know what will happen next year.
Right.
We may say yes, maybe this was so large because it was drought, but it may still be within this trend of growth of subsidence with the rates which we saw for previous years. We have to see the trend that it's really evening up, and especially that it's so close to this specifications category between 0 and 1. If there would be, let's say, construction planned for the larger structures, then this category 1 should be somehow considered.
Anything else quickly anyone has? Thank you very much, Anna, for your presentation. Lots to digest there for us, and we'll have a look at it. Obviously, we have the slides now available, and we can go through them again, and individuals as well. I take it to be like one of those stories where we got some good news for you and we got some bad news for you. The good news, you're a zero category, but the bad news is you had a major shift in, somewhat major, compared to the last 8 years in the last year. So we'll be curious to run that to the ground. Bad choice of words, but we'll be curious to get to the bottom of that. Another bad choice of words, to find out what maybe is trending there. So appreciate your work to this point in time. Thank you very much for the presentation. Appreciate it.
Thanks, Anna.
Very much. And,
Bye-bye.
and I enjoy cooperation with the town of Westfield, and I hope that, the next year the news will be better or will be more not dramatic. So
Right.
Thank you.
Thank you.
Bye-bye.
Thank you.
You want to take that down, Scott, to get us back on,
He's got to get the other one
get
in.
us back on whatever we are?
Get water. Anybody want some?
Yeah, please.
Would you grab me? Yes, of course. Thank you.
Okay, so we're just going to queue up the next presentation, I think, on the geothermal presentation. Kind of a segue into geothermal, I guess, talking about the underground mining that we had and so on. Interesting stuff.
Hi, Anna.
Hello. How are you?
I'm good. Are you all alone, or is Ellen with you too? There she is, it looks like.
Lynn is here too. Hello.
Hi there.
Thanks,
Okay,
Sarah.
so, sorry, my apologies for being late. Our previous
Thank you.
presentation went on a little bit long, so my apologies. I'll turn you over to the mayor to
Oh.
introduce you.
Oh, thank you very much. Welcome. You're going to have to introduce yourself because we haven't met, unfortunately. This is Mayor. I'm Mayor Lenny White. With us, so you know, is Mayor Dunn down to my right here. Your left, I guess it would be.
Mayor Dunn?
Sorry.
Not yet.
She got promoted. She's Councillor Dunn to this point in time. I'm still here. I'm still the mayor. CAO Weirs, obviously. Down to my left, Recording Secretary Reed down at the far end. Next to her is our Councillor Fraser and Councillor McKinnon. We have one other councillor, Deputy Mayor McGregor, who's under the weather tonight and couldn't be with us, but he's going to watch the presentation later. So, just so you know, we broadcast on YouTube, so it'll be there for people to look at after this evening as well, for a long time until we take it down in like 20 years or something, I think it is, yeah. No, I'm just kidding. 3 years, I think it is. So over to you. Looking forward to the presentation.
Great. Thank you. Really nice to meet you all. I can give a quick introduction myself, and then I'll pass you over to Ellen. I'm Hannah Jordan. So I work in ARIP in the Toronto office. I'm a sustainability consultant, and I've been with ARIP for 7 years. I have a background in sustainable strategy, resilience planning, and climate adaptation. And I was the deputy project manager on this project. And I'll pass you over to Ellen.
Thank you.
Thank you. Hello, everyone. I'm Ellen. I'm a senior sustainability consultant at ARIP. I'm a mechanical engineer as well, so I bring my mechanical engineering background to decarbonization and sustainability projects like this.
Thank you.
Just wanted to check that you can see our slides.
Challenging, but
They're up there.
yeah, they are up there. We've got
No, they're not up there.
challenging,
On the computer, Lenny.
Oh,
challenging computer realities here that we're trying to. So I think this is as good as we get. So I think it'll be essentially impossible for everybody to do the slides. So I think you just talk your way through it if you could.
Just give us one moment.
one moment, please.
Somebody is able to do this better than I.
Maybe.
I can give a quick intro to the quick program.
Yeah, please do.
Yeah, as a starter, while you're bringing, if you show us closer. But basically, the background to the CRISP
Okay, thank you.
Great. Just let me know when you're ready if you want to.
Yeah, we're still trying,
Yeah, I
We're-
think just proceed, Ellen,
Yeah.
as best you can.
Okay, yeah, sure. I'll try to just enunciate a little bit more of the content that I have on the slides. It's really just a guide anyways, but so our work, as Hannah mentioned, was primarily a geothermal feasibility study driven by high cost of fuel for the two buildings
Wow, I
that
need
we
to
looked
get-
at in Westville. And so we worked to determine the technical feasibility of using a natural spring as a heat source for these facilities. And we compared that with kind of more typical heating system option.
Ellen, if I could just interrupt for half a second. So we have categorically failed to bring your slides up on my computer. It may be a bandwidth issue. I'm not exactly sure what's going on. Anyway, just for council, just as a reminder, in the Pioneer Coal area, under the what's it called? Drummond Pathway? Yeah, Drummond Path area. There is at the bottom of the hill a spring that has run, as everybody in Westville knows, for decades and decades and decades and decades, and that it brings up water that it never freezes in the winter. So the water comes up, it's at about 10 degrees Celsius. And so that was the source or the impetus for seeking out Hannah and Ellen to take a look at that well or that spring for us, so that we could understand whether geothermal was possible on the basis of a relatively low flow and relatively low temperature natural spring. So after that, go ahead, Ellen.
Yes, thank you. So, yeah, helpful context there. These two buildings are the 2042 Queen, which is the town office and library, and then the 2020 Queen Street, which is the police station, fire department, public works building. So these two buildings are located very close to that Drummond Path spring that you're mentioning, and so yeah, the opportunity is kind of too good not to investigate if that would be a feasible source of heat for these buildings. And currently the buildings are heated by oil and propane. So as I mentioned, there's high fuel costs to running these buildings, as well as high emissions. So even though you can't see my slides, I'm still going to use them. So you're not going to get to see the helpful graphics, but I will refer you to the report that we submitted to you guys.
we
so
move
you
that
can
closer
take
to
a
us?
look at the graphics and some of the
And Ellen,
from the study.
Ellen, they've all seen your report, so it was sent out to them some time ago. So they've seen it already.
not that
Okay, great.
close.
So, kind of the main first result of the study, I'm getting a little bit of an echo from that. I don't
Yeah,
know if
just
you're
like-
fine with that. Continue.
How's that?
That's fine. Yeah, that's fine. Thank you. Yeah, good. Okay, so first thing we looked at was the GHG emissions of using a heat pump to capture heat from the spring and bring it to the buildings. And when I say heat, I also mean heat in the heating season and cooling in the cooling season, so the system can do both. So we looked at a geothermal system option, and we also looked at an air source heat pump option, which is kind of a more typical system that you'd see dropped into any building that's not kind of advantageously located by a spring. So we compared these two options, and kind of interestingly, based on the present grid emissions in Nova Scotia, the all-electric geothermal option actually didn't perform as well as a kind of a hybrid air source heat pump option. And that's just because although the geothermal only uses electricity, the grid makeup of Nova Scotia is a little bit dirtier than just actually burning fuel on site. to support the kind of extreme heating temperatures that you see. On geothermal, you don't need that because you have that relatively constant temperature coming from the spring. So that's kind of the difference between those two systems. So at the present grid factor, the air source heat pump option was better. However, Nova Scotia is projecting to significantly improve grid emissions and kind of green the grid in the next couple of years. They have a 2030 projection that it's going to be 10 times better than it is right now, which is an important consideration for you when we're comparing these two options, because when we model that, the geothermal option becomes much better than any of the other options. It could kind of also to summarize this point, currently your emissions are at like 300 tons of CO2 for those two buildings, and in an ideal world where they do green the grid, your emissions drop to 20 tons of CO2. So it's quite a significant reduction in emissions. Even without the greening of the grid, the air source heat pump option drops the emissions to 174, so almost halving the emissions of the building currently. So that's the emissions story. The next thing we looked at was cost. So both of these options kind of have to acknowledge that there's some significant deferred maintenance costs associated with this type of project. Both buildings are aging, older infrastructure, kind of legacy systems, so you wouldn't be able to implement either of the discussed options without kind of addressing some of those existing system updates that are needed. So that's things like updating the air handling system, which we've heard has some kind of controls issues and braking issues, maybe not operating up to code at this time, and other kind of miscellaneous controls and maintenance of the systems. So that is kind of, those costs are kind of taken aside from the comparison of the costs of the air source heat pump and the geothermal options. So those total to around 870,000 as a high level estimate for those costs. And then the CapEx of the new system for the first option, which is geothermal, is around 725,000, and the second option is the air source heat pump, which comes in a little bit lower than that at 520,000. So these are maybe costs you can refer back to our report on if you want to look at the finer numbers, but to kind of illustrate, the air source heat pump option is less expensive. However, both options kind of have a similar payback because the geothermal running on electricity is just a little bit more cost effective. So your utility bills are going to be a bit lower, and you'll get a little bit faster of a payback despite a higher outlay of capital cost. Yeah, so for context, your 2024 annual fuel expenditure was around 180,000, and the geothermal option saves you about $85,000 annually, whereas the air source heat pump option, which has electricity and typical fuel, saves you around 41,000 in fuel, in operational. Excuse me. So my next slide is kind of an itemized cost estimate. I won't obviously read that to you, but again, both options require that deferred maintenance to be addressed, as well as kind of an electrification preliminary works to update the building services to be able to support these newer systems that rely more heavily on electricity. So each of these also comes with kind of an estimated $300K in electrification costs for the sites, which includes electrical upgrades and also kind of a high temp to low temp conversion of the building, where it's maybe a little bit more technical, but your old school steam systems aren't compatible with kind of new age technology that relies on electricity to do the heating. Sorry, I have a frog in my throat. Okay, so yeah, you can get a little bit more of a detailed itemized cost breakdown if you look at the report, but excavating and trenching the distance to the spring. There's more pumping, there's more piping, around 500 meters of piping. So it's a little bit more of an involved system and a little bit more complex, and therefore it has higher cost. Also to mention that the costs we generated or estimated are exclusive of additional fees for studies, permits, environmental, all of those any kind of remediation and such. Just to note that. So in conclusion, our recommended option is the air source heat pump option. It is less capital intense. It is maybe a little bit more of a conventional solution. There's less risk around it with allowances, ownership and entitlements, less stakeholders, minimal environmental and wetland impacts, which you have more issues with the geothermal system that you're trying to kind of build into that wetland. Operational unknowns and perhaps servicing also in the area. It's maybe the geothermal is maybe a little bit more of a complex system, and maybe more delicate system that may be more difficult to maintain. I've already mentioned the kind of efficiency is there. They're both efficient systems. The air source heat pump kind of mitigates the transition from kind of a fuel heavy grid to an electrical grid. So it's just another consideration to kind of keep in mind as you lay out the timeline for this work. Yeah, those are the kind of the main, in summary, kind of the main points that we would underline in our decision or in our recommendation to choose air source heat pump over geothermal.
Right. Thank you, Ellen. So just for council, just a couple more things to think about that are coming up as a result of some of the things that Ellen was just saying about the geothermal. For example, that piping that she's talking about would have to cross the Pioneer Coal lands. So we'd have to engage with a landowner. That whole area, of course, was excavated as part of an open pit mine, and as the previous presentation demonstrated, subsidence is still going on. And so we'd be laying our pipes through an area of land that is subsiding and has been subsiding for over 35 years, and on the basis of Anna's work this year with us, looks like it's going to continue to subside for a while yet. So those are, additional challenges that are also out there with regard to the geothermal, and those are things that I didn't have those results when Hannah and Ellen started doing this work, right? We had that work with Anna underway, but we hadn't had the results yet. And so those only came well and truly after Hannah and Ellen had done all of their work, right? So there are, as Ellen is saying, there's multiple complications associated with the geothermal. Sexy and kind of 21st century though it may be a bridge too far for Westville right at this time, given some of those realities. And then there is the whole point of, this building, it will need significant electrical upgrading to deal with kind of the loads that heating and cooling it all by heat pumps would require. And so those are challenges or costs that we need to be thought through. So sorry, back to you, Ellen and Hannah.
Yes, thank you. So that's a perfect summary, and I kind of just, the last thing I'll do is just outlay the next steps that you should take using the results of these studies. So number one being, look at modernizing those two existing buildings and consider the capital expenditures you'll need to get them kind of up to modern standards and to have the ability to then upgrade to a new system. And you can get detailed costing on that from a local contractor, or get maybe a more detailed understanding of what those costs are from someone who can be on the ground and the building.
And when you say
Um,
that, Ellen, I think what you're saying is additional insulation, new windows, new doors, those sorts of things that are not 40 years old, right?
Yes, and just looking at what's there in your system, like we did a high level estimate, you'll need new air handlers, you'll probably need to do some pumping and upgrades
Right.
like that.
Yeah.
But without kind of being on site and looking at what's there, we can't truly get an accurate estimate. We've got you a feasibility level cost estimate of what we think,
Right.
where you're starting, but ideally you go ahead before you, so that you can make better decisions on the building, go ahead and get a contractor or, someone with building systems expertise to go through and give you an idea of those costs, including windows, including insulation, because they may support your decision, they may improve the impacts of your system decision, or you may decide that the windows is cost prohibitive and you just want to focus on getting the HVAC system kind of up to date. So yeah, we do list, that's my second point, is to consider the list of energy reduction measures that we go over in the report in the appendices, to just get other ideas of, energy saving measures that may be synergistic with a system replacement. So yeah, maybe it's windows, or maybe you're planning already on doing a new roof. Maybe you upgrade the roof insulation when you do that. So just kind of consider this system update amongst the other kind of capital expenditures that you're planning for those two buildings.
Perfect.
Next step I have here is to step 3, consider gathering more information on the spring characteristics and better understand the approvals. So it sounds like you've kind of already got some more insight into kind of the difficulties or challenges with implementing the geothermal option. So yeah, you can get more information there. You can kind of summarize that when you're making your decision. And lastly, consider the timing of the implementation and grid readiness. So, if you're not planning on doing this work for 5 to 10 years, maybe a different solution sounds better, or, maybe you can just optimize the implementation based on what you see happening with the grid and fuel costs and such. So, yeah, that's the last point.
It would be based,
And-
the other thing, it would be based on available funds for this type of retrofit of buildings such as that we have currently here. What funds we can tap into, because there's no way in this world that we're going to come up with the funds that you're talking about to do it on our own. That's for certain.
Yeah, yeah.
The other quick question I had was with regard to the geothermal, where it exists over there in the park. If there was development on those lands close to the source of that spring and so on, am I right in saying then, from it would be more feasible to utilize the geothermal aspect for that area?
Yeah, I mean, the 500-meter distance was significant. The fact that you have to cross a road and get approvals for those lands is definitely an extra challenge. So if those were eliminated, I could see it being more of a desirable solution. But that being said, and our report kind of goes into this a little bit more, we don't know for sure what the exact temperature of the spring is year-round. We don't know how much it fluctuates, and we also don't know how fast it flows. So we weren't able to do an extremely detailed, model of how much heat you could get out of it. Right. But based on the info that Scott shared with us and the assumptions that we made, we figured that it could support the two facilities that we looked at. But before making any of those kind of decisions, you would need to get that confirmation of what exactly is flowing there. What are the do a year study to
Right.
see, okay, what's the temperature throughout an entire year?
Yep.
So initially, I think when we went down this path, we were super hopeful that it was going to come back hotter than what it did. So it came back at about, what did you say, like 10 Fahrenheit?
in
Yeah.
that zone.
What would have
10
been?
Celsius.
What-
10 Celsius,
10 Celsius.
50 Fahrenheit.
Yeah, so if, like, what would have been the ideal? Like, if we were like, oh, this is something we could really have a lot of potential with, would that have been something that was like 80, 90, 102? Like, what would have been the jackpot there?
I mean, we modeled it at 10, and
Yeah.
we modeled a few different flow rates, and all of the flow rates we modeled, which I don't know off the top of my head, but all the flow rates we modeled were feasible to heat the building. Obviously, the hotter the water and the more
Yeah.
it's flowing, the more heat you're getting out of it, so that just means the efficiency of the system improves. But the system that we modeled had like a typical efficiency, had those kind of lower temps and flows that we talked about, and still paid back. So I think it's still, like, it could have been a really great, I don't think it was a waste of time to
No.
investigate.
No,
It
not
could have
at
really
all,
been
no.
awesome, but just because of all the other kind of unknowns and risks.
We were,
and challenges.
Alan, we were kind of hoping for hot springs, you know, from a touristy
Yeah.
perspective, that we could advertise, you know, come to the Westville Hot Springs, you know,
Yeah.
for your
Taking people
winter
from Banff.
vacation.
That's right, to Westville.
We'll let another council of another day worry about that one, I guess.
Any other questions?
Yeah, that's all I
That's
have.
it? Okay. No, that's interesting stuff. You know, and it's valuable stuff because you don't know what you don't know. And now we know a little bit more, so
Well,
it's
and-
all
and I
good.
think, you know, Mr. Mayor, that the work that Hannah and Ellen and their colleagues have done for us kind of puts Westville in a spot now where we can start to think about other approaches, right?
Right.
And so it's the first of, you know, I think to Ellen's point, more investigation is needed.
Right.
About both geothermal, but just about this building.
Right.
Yeah.
And it starts to put you in a place where, as a council, you can start to say, okay, well, what is the lifespan of this building? And how much do we want to start investing in this particular building?
Versus another move somewhere.
Versus some other approach, right? And so these are the kinds of studies that you have to start with and start to build into your strategic plan for, on a capital, you know, and office basis over the next little while. So do you want to move to taking the post office building, for example, at some point downstream and turning that into
Civic
with
Center.
some additions into the town hall, right? As opposed to being using this building. So it starts to give you some basis upon which you can rationally start to plan in a kind of more strategic way, right? So more
Yeah.
work, yes, needs to be done.
Well-
But you need to make some decisions about, you know, how much longer do we want to be in this building? Do we have alternatives? If yes, what are those? Where's the money gonna come from those? So it gives you a whole new,
Right.
kind of approach to making decisions about, this building and where Westville wants to go over the next,
Right.
10, 15 years.
Oh, yeah. Both these presentations tonight, the one previous to this one on subsidence and this one on geothermal, you know, fall in line with what this council decided as a go-forward sort of policy during the term of this council, and that was to, base every decision on good evidence, good information, relying on experts such as yourselves. And so, you know, to me, you know, both presentations in the evening, sort of complement that sort of approach that we decided to take. So much appreciation to the work that you've done in conjunction with Scott here, who unfortunately is leaving us after this week. We're going to miss him greatly, and I'm sure you guys will. I'm sure that you've had a good relationship with Scott. It would be surprising if that was not the case to me, and we appreciate your work with Scott, and we hope to continue with someone else in the chair. Hopefully, continue the work that when we need to go through those next steps that we talked about here this evening. But thank you very much for everything to this point in time to help us understand better, you know, some of the choices that we have to make and maybe the direction we should be going. Much appreciated, really.
Yeah, thank Thank you, and it's been a pleasure working with you and Scott, and it's really exciting to see a small municipality such as yourselves asking these questions and taking these strides for sustainability and energy efficiency. So really happy to have had the opportunity to work with you on this.
Thank you, Ellen.
Thank you. Thank you, guys. Appreciate it.
Thanks, all.
Take care.
Bye.
Thanks so much.
Take care. So, whoa, we got a weird thing going on here. It's up because it's up here? I don't know.
Well, it's because this thing is here.
Oh, yeah, that, okay, oh, it's that thing, that's right. Keep forgetting I didn't know where the camera is, need a director, right? So, I guess that brings us to the end of the meeting. Next meeting is our regular council meeting on 1 week from today, March 30th. It's amazing when I said that. 1 week from today is March 30th, scary. So, before we do that, just very quickly for public compensation, to know that this is Scott's last official meeting with us as a council, unfortunately, sad to say, but we totally understand Scott's rationale and need to move back to Ontario. We wish him well in that, and I just want to emphasize once again tonight the two matters that we just dealt with. Are not things that we were looking at or had moved forward until Scott came on the scene and saw immediately, the challenges that we had with subsidence and not knowing, the big thing about the subsidence, and I've said this as well, is that, we just need to know. We need to know the good, bad, and ugly. We need to know if parts of town are good, parts of town are not so good, and get on with life and be able to tell people that. Scott saw that challenge. This is just one example of what Mr. Weir's brought to the table as CAO in town, and we are forever, ever appreciative and grateful for the last 3.5 years, or 3 3/4 years, I guess it is more like, that Scott's been able to be with us, and we wish him nothing but the best, and for he and his family as he moves on from Westville. Much appreciated, Scott. Thank you.
Thank you.
So with that, I will declare the meeting adjourned.